Now the question is, inside a semicircle of radius 1 unit, two circles of radius r1 and r2 are drawn, each touching the circumference and diameter of the semicircle and also touches each other externally. Then this box maximum r1 plus r2 is where this box x represents integral value nearest to x. So it is not greatest value function of x. Now here we have the semicircle. And then we have two circles touching each other and also this semicircle. Let this point of contact be A and this be B. And if we draw their common tangent, let this be M. Now basically these three lengths, they'll be equal. Now suppose this is C. Now suppose AM equals MB equals MC and let it be A. So let this distance be A. Now we know that AB is length of direct common tangent between the two circles. Now radius of this circle is say R1 and radius of this other circle is R2. Then we know that AB is equal to 2 times under root R1 R2. So basically these lengths AM, BM and CM, they are under root R1 R2. Now suppose this angle is theta. Then if from the center we draw perpendiculars, then this is R1 and this half angle is theta by 2. So we can write tan theta by 2 as R1 upon A. So this R1, it will be A tan theta by 2. And in the same way, for this second circle, we know that this angle is pi minus theta. So this half angle is pi by 2 minus theta by 2. So it will be this A cot theta by 2. So we've got R1 and R2 in terms of A and theta. Now suppose center of this semicircle is at O. Then if we join these two and these two, this length is 1, then this length C1O, it will be 1 minus R1. And the same way, this C2O, it will be 1 minus R2. Now this AC1 is R1 and BC2 is R2. Then from here we can write this AO square, it will be 1 minus R1 square minus R1 square. So it will be 1 minus 2R1 and the same way BO square is 1 minus 2R2. Now we know that AO plus OB, it is AB and AB is 2A. So from here we can write under root of 1 minus 2R1 plus under root of 1 minus 2R2, it is equal to 2A, and R1 is A tan theta by 2. So it will be this 1 minus 2 A tan theta by 2 plus under root of 1 minus 2 A cot theta by 2, and it is equal to 2A. Now what we'll do is, we'll take this cot expression on the right hand side and we can write under root of 1 minus 2A tan theta by 2 will be equal to 2A minus under root of 1 minus 2A cot theta by 2, and if we square it, we'll get 1 minus 2A tan theta by 2 will be 4A square plus 1 minus 2A cot theta by 2 minus 4A under root of 1 minus 2A cot theta by 2. Now here this 1 and 1 will cancel. We'll cancel this 2a also. So we can write this as cot theta by 2 minus tan theta by 2 minus 2a will be equal to minus 2 under root of 1 minus 2a cot theta by 2. Now we'll square it again. We can write cot square theta by 2 plus tan square theta by 2 plus 4a square minus 2 cot theta into tan theta is 1 minus 4a cot theta by 2 and plus 4a tan theta by 2. It is 4 minus 8a cot theta by 2. Now we can write this as cot square theta by 2 plus tan square theta by 2, and here it is plus 4a, and here we'll take cot theta by 2 plus tan theta by 2, and then we have this minus 6 plus 4a square equals 0. Now what we'll do is we'll add 2 and subtract 2, so we can write this as cot theta by 2 plus tan theta by 2 whole square plus 2 into 2a cot theta by 2 plus tan theta by 2 and plus 2a whole square, and it will be equal to 8. Now this is a square plus b square plus 2ab, so we can write this as 2a plus cot theta by 2 plus tan theta by 2 whole square, it is equal to 8, or 2a plus cot theta by 2 plus tan theta by 2, it is equal to plus or minus 2 root 2. And since a is positive and these angles theta by 2, they are acute, we are going to consider only positive values. So this is 2 root 2. Now this is 2a, and if we change it in sine and cos, this is cos upon sine, sine upon cos. So cos square theta plus sine square theta will be 1. So it will be 1 upon cos theta by 2 into sine theta by 2. We'll multiply and divide everything with 2. Now this 2 here will cancel. We'll get this as sine theta. So this a plus cosec theta will be equal to root 2, or this a is simply root 2 minus cosec theta. Now we already know r1 is a tan theta by 2 and r2 is a cot theta by 2. We have to find maximum value of r1 plus r2. So it will be this a and then tan theta by 2 plus cot theta by 2. Now this is a. Now again we'll change it in sine and cos. So it will be this 1 upon sine theta by 2 cos theta by 2. We'll multiply and divide everything with 2. So it will be this 2a sine theta. Now a is root 2 minus cosec theta. So we can write this r1 plus r2 as, now this is 2a and will be this 2 root 2 minus cosec theta upon sine theta, which also is cosec theta. So we can write this r1 plus r2 as 2 and then root 2 cosec theta minus cosec square theta. Now this r1 plus r2 is a function of theta. We have to maximize and minimize it. Now we'll differentiate this. So let this expression be e. So we let dE upon d theta will be 2 and then root 2, and cosec theta is minus cosec theta cot theta and then minus 2 cosec theta and then minus cosec theta into cot theta equals 0. So from here we get either cosec theta is 0 or cot theta is 0 or cosec theta is 1 by root 2. Now cosec theta cannot be 0 and cosec theta cannot be 1 by root 2. So the only critical point that we get here is cot theta equals 0. That means theta equals pi by 2. So we have this critical point at pi by 2. Now we have to find sine before and after pi by 2. So what we'll do is we'll take up general point pi by 4. Now cosec pi by 4 is root 2 and cot pi by 4 is 1. So this is 2 into minus 2 and this is plus 4. So this is plus and minus. So we'll have a local maxima at pi by 2. So it is a point of local maximum and we have to find maximum value of r1 plus r2. So we'll get maximum value of r1 plus r2 if we put theta as pi by 2. So if we put theta as pi by 2, then this r1 plus r2 max, it will be, now cosec 90 is 1, so it will be this 2 into root 2 minus 1. So the maximum value of r1 plus r2 is 2 times root 2 minus 1, which is nearly 0.83. Now this is not greatest linear function. This is integral value nearest to x. This value is 1 and that is the answer to this question.